Okay, this is the Chapter 1 video, Lesson 8, all about something called slope. Really quick video, don't have a whole lot of notes for you. Let's jump right in. So, vocab, very easy vocab today, slope. Slope is the steepness of a graph. Okay, there's your definition. Slope is the steepness of a graph, and you're wondering, how does this fit in with Chapter 1 stuff? You'll see very, very soon. Slope is the steepness of a graph. We have some notes here. The slope formula. This is going to look very familiar to you. Are you ready? The slope formula is delta y, oh my goodness, over delta x. I've seen this before, haven't I? Yeah, certainly. Slope is just the rate of change of a line. Okay, slope and rate of change, exact same thing. Rate of change we usually talk about with a table. Slope we talk about with a graph, same thing. Delta y over delta x. How are the y's changing over how are the x's changing? Okay, you got this? All right, I hope so. Let's take a look. Slope can be thought of as rise over run. And what that means, let me write this in, then I'll tell you what that means. This is going to make a lot of sense in a quick minute. Slope can be thought of as rise over run. Well, think about the coordinate plane. Okay, so delta y is the change in the y coordinate, and that's how far you are rising. Okay, and delta x is the change in the x coordinate. How far are you running? So slope is rise over run. How far are you rising to run? How far are you going up to go over? Okay, so we'll talk about slope really, really soon here. Again, slope is the steepness of a graph. When you make your vocab card about slope, I would put all of these things on it. Okay, slope on one side, and then the steepness of a graph. The formula is delta y over delta x, and this phrase, rise over run. Okay, all on the slope note card because they're all really important pieces of slope. What we're going to do is we're going to talk about slope. We only have one example today because we are going to talk about how to find slope when you are given a table. Okay, we'll do the slope of this table. We'll also talk about how to find slope when you are given a graph. Okay, very, very easy. Delta y over delta x. This is the stuff. This is very, very quick. Let me just write my formula up here so I don't forget. Delta y over delta x. Let's read the problem. Example number 1, graph the data about plant height for a science fair project and then find the slope of the line using 2 separate methods. Well, our first method will be the table and our second method will be the graph. And then we're going to explain our slope using a little bit of rate of change language. Very, very easy. Let's get right to it. All right, so we'll do it in the table first. The table, the weeks will be our x values, the height will be our y values. And that means we have to find delta y first and delta x second. So delta y, 8 to 11, 8 plus 3 is 11, so the change is plus 3. 11 to 14, same change, 3. 14 to 17, same change, 3. Let's look at the weeks. Those are our x's. Week 1 to 2, that's a change of plus 1. Week 2 to 3 is a change of plus 1. Week 3 to 4 is a change of plus 1. So let's put together our slope here. Our slope is delta y, which is 3, over delta x, which is 1. So my slope is 3 over 1, which means I'm going to rise positive 3 and run positive 1. Okay, so slope here is 3 over 1, or the whole number 3. My explanation, if I want to get more technical here, my explanation is 3 inches, remember the y's are the inches, per 1 week. So when I type this out, I'm going to write, for every 1 week, the plant grows 3 inches. There we go. There's my rate of change language, which is, of course, my slope language, because they're the same thing. Let's take a look at how we would find the slope of a graph. This is very quick as well. This is our second method. It says using 2 separate methods. So first I have to graph what I've been given. Week 1, the the plant is 8 inches tall. 1, 2, 3, 4, 5, 6, 7, 8. So there's my point. Week 2, the plant is 11 inches tall. There's my next point. Week 3, the plant is 14 inches tall. And week 4, the plant is 17 inches tall. Oh my goodness, oops. There we go. Let's take a look at that. What do you notice about that graph? That graph is linear. That graph is linear. It doesn't pass through the origin, so it's not proportional, but that's okay. Remember, rate of change has nothing to do with being proportional. Rate of change has everything to do with seeing if it's constant, seeing if the units are changing together. In this case, are the inches changing at the same rate every week? And the answer is yes, because we have this beautiful linear graph. I want to make sure that we remember that word, linear. Linear. And a linear graph tells us something. A linear graph tells us that this is a constant rate of change. And we knew that already because we found the slope in our old method first, our rate of change way first. But this time it even confirms it because it's linear. That is a huge deal. I want you to write that on your notes. In your notes, I want you to circle it. I want you to make sure that stands out. But the idea of being linear tells us that it is a constant rate of change. Okay? Linear and constant rate of change, they go together. I'm going to put constant ROC here. ROC stands for rate of change. But linear means it's a constant rate of change. It has nothing to do with going through the origin or being proportional. Who cares? That doesn't matter right now. The linear graph tells us that it is a constant rate of change. And what we can do now that we know it's a constant rate of change is we can find that slope. We can find that slope, and we do that by writing our points here in the graph. And our first point was 1, 8. Okay, and our second point here was 2, 11. And our third point was 3, 14. And our fourth point was 4, 17. And since this is a linear graph, since the line is straight, we only have to find delta y over delta x in one spot. Okay, from this point to this point, or we can choose those 2 points or whatever, but we only have to find it once because it's linear. That's really important. Really, really important. So I only have to find delta y over delta x once. Take a look at my delta y's here. 8 to 11, that's a change of plus 3. Take a look at my delta x here. That's a change of 1 to 2, so that's a plus 1. So my slope is delta y over delta x, 3 over 1. Same thing we found in the table, but we can do it on the graph as well. And remember, since we see the graph, since it's linear, which is super important, right? Super, super important, we only have to find the rate of change between those 2 points. And my slope is 3 for every 1 week the plant grows 3 inches. Okay? Go ahead and finish up your practice problems. Ask any questions tomorrow in class. Update your flashcards. This is an awesome lesson. This is going to have application for us again later on in the school year and in Algebra 1 and Algebra 2. So please, please, please pay attention to slope because it is very important.